Hello, my name is Jacob Hardy, and today we're going to be talking about eclipses. Now, this is important to know because if you think about it, an eclipse happens and the sun disappears out of the sky and it's suddenly super dark out. You have to know that the sun is going to come back and that it's not some mystic sorcery, that it's going to be okay and that it's not going to happen at just some inconvenient time. Imagine racing down the road and then suddenly the sun is gone and you can't see where everything is. It could be really dangerous. So you need to know that not only is it going to be okay, the sun is going to be coming back, but we know when and where these events will occur. Plus, they're super cool to look at, so we'll get started. Now, before anything else, you should already know that the sun, the earth, and the moon revolve in a very cyclical and measurable pattern around each other. The earth rotates around the sun, the moon rotates around the earth, and in addition, the earth is constantly rotating around its axis. It's spinning like a top, and this creates our days. The Earth's surface rotates underneath the constant light of the sun, and experience different times of the day. Light is in addition can be absorbed and reflected by any surface. These surfaces then reflect light into our eyes, and this is how we see. We need reflected light in order to see images and to see color. In addition to that, the lunar cycle is determined by this reflection. So our lunar cycle, our full moon and our new moon and the waxing and waning in between is entirely determined about what side of the moon is facing the sun and is able to reflect light to our eyes. Do you have any questions about these concepts before we get in? Okay, hearing none, I'm going to move on. But if you have any questions, write them down and I'll be happy to answer them later. So what happens when you put something in front of a light? Well, we're going to create a shadow. The light right here is our light source. This is going to send light in every single direction in a total 360. That includes in this direction towards our black body. This could be anything. This could be anything with mass and is able to absorb and reflect light. So light coming from this object will either be absorbed or reflected back at it or in any other direction thereof. But unfortunately, it cannot pass through the mass, and so this is where we create a shadow. Light over here is not able to the light is not able to transfer through this object and then into this space. So this space is much darker and thus receives much less light than everything else around it. However, as you move farther over from this space in between these two lines, you'll see that we get to see part of the sun. And so this was a little lighter of a shadow because you get to see some of the sun, but not all of it. So this is a little lighter shadow, and this will be our darker shadow. And then as we move even further out of the way, we get to see even more sun and thus receive more light, and it's even lighter until finally we're outside of the shadow cast by this body, and so we get to see all of the light. Now, the same concept applies to the sun, the moon, and the earth. The sun will always be our light source, but the moon and the earth can sometimes trade places, being that black body that either absorbs and reflects light and thus casts a shadow. So, from our perspective, these objects then seem to disappear because they're obscured or blotted out, and so no light is reflected off towards our location. But it's also important to note that this is always from the perspective of the Earth and not from the sun or the moon. So we always will look at things from the Earth's perspective. Now, this is the same diagram that we just looked at, only with the sun, the moon, and the Earth replacing those objects. So the sun is our light source, and this is the moon, which is our black body, and the Earth is our surface that has the shadow cast on it. And the sun is so much bigger than the moon, so that these lines that we see aren't going to be the straight ones that we see before, but they're going to be angled and they're going to make this conical shape that we see here. And so that's why we see these conical shapes, because the angles here are so much more intense than the ones before. And so we have a huge area here where we have a light shadow, and we have a much smaller space where we have a dark shadow. This dark shadow, as you can see, is called the umbra. The umbra is the dark shadow area, and this is where we actually experience what we call a total eclipse. The penumbra is the area where we experience a partial eclipse. This is the area that receives a little light, but not all of the light. Now, it's important to note that the moon fluctuates its distance from the Earth, and because of the conical shape of those lines there, sometimes they don't always make it to the Earth, and so we don't actually have a point where the umbra, this dark area, touches the Earth. this means we actually don't have a total eclipse. Instead, we'll get something called an annular eclipse or a autumnal eclipse right here on the surface instead. And that happens because we can still see parts of the sun actually, because the moon is farther away and thus appears smaller and thus is not able to cover the entire sun. So it's important to note that the closer an object is, the bigger it appears, and the farther it away, the smaller it appears, and eventually the moon is too far away to completely cover the sun. And so once again, we have an umbra, penumbra, where we see partial, and then we see you have the antumbra, which is actually a darker shadow, but not nearly as dark as our umbra, where we can't see anything at all. So now we're going to look at a quick video. I'm going to pause this. So right here, we're looking at a quick video of what it actually looks like when the moon moves in front of the sun. So what happens is that the moon moves in front right here, and it actually obscures our entire vision. Look, you can see the night sky because the sun's light is being completely blotted out by the moon. Now, it's not going to cover up everything, but it is going to cover up pretty much all of the light that we're going to see. And then as it continues to revolve around the Earth, it's going to move out of the way, and we're going to see the sun again. Right there, what we just saw was a solar eclipse. This only occurs when the moon moves in between the Earth and the sun and obscures the sun. Now, there are two kinds of eclipses, and the other eclipse that we see is a lunar eclipse, and this occurs when the moon actually moves behind the Earth, and so the Earth's shadow covers up the moon. Now, sometimes this can be a little confusing, so I've included this little rule here where eclipses are named after the object that is obscured. So a solar eclipse is when the sun disappears, and a lunar eclipse is when the moon disappears. So keep that in mind for the rest of the presentation. So this is what it actually looks like, because we already saw lots of the solar eclipse where the moon was in front of the Earth, and so the sun appears to disappear from our sky. However, this is what happens during a lunar eclipse. The moon moves behind the Earth, and the Earth casts its own shadow and own umbra and penumbra. Notice how the umbra is much bigger than the moon's umbra. The Earth is able, as a much bigger object, to cast a much bigger shadow. So, our solar eclipses can only occur when it's a new moon. That's because the moon is in front of the Earth and in between the Earth and the sun, and so it is able to blot out the sun. However, if it's too far away, we get what is called an autumnal solar eclipse, and that's what we talked about before, and this is what it actually looks like. It's called sometimes a ring of fire because it can't cover up that little ring of sunny flame. But this right here is what it looks like normally when a total solar eclipse occurs and we can't see any of the sun. And this area is actually called the corona. This is the energy that actually circulates around the sun, and we'll talk about that more in a different time. So this actually when their next solar eclipse will occur, April 8th in 2024. This is the next time it'll occur in North America. And you should know that this point that is where totality occurs, that total solar eclipse occurs, is actually stationary. It's a one point on the Earth, and that the Earth's surface is what actually rotates underneath it. So this point stays in one spot right here, and then the Earth moves underneath it, and so it appears to travel across the Earth. Now, lunar eclipses happen much more frequently. That is because, one, the Earth has a much bigger umbra, and because the moon moves in that area much more frequently. Now, totality occurs when the moon enters into the Earth's umbra, but oftentimes what we experience is a partial lunar eclipse much more frequently. This occurs when the moon enters into our penumbra, which is proportionally much larger than when the moon moves in between the Earth and the sun. Now, this only occurs when it's a full moon. This is why it's important to remember the lunar cycle, because a full moon is when the Earth is in between the sun and the moon. And so the moon receives the full energy of the sun's light, anyway, that's facing us. And so we get to see that aspect. Now, we never will see any autumnal lunar eclipses. This is because the Earth's umbra is so huge that the moon will never be far enough away to actually enter into the autumnal space. Now, that concludes my presentation for now. We will actually go right into our activity, but feel free to ask any questions or anything now. Thank you for your time. This right here is my works cited page. Remember, it's MLA format for you all your projects this semester, and so I will do likewise the same. All right. Thank you for your time. Have a great day. Goodbye.